Greetings and welcome back to the Patterns and Practices Symposium 2012 online. We have the dynamic duo of Juliet and Grigori back with you. And for people who are continuing watching the symposium, we promise that this is not going to be the whole day that two of us are talking.
This is our last talk.
This is our last talk, in fact, for today. But let's just make sure that we introduce ourselves for those people who are just joining us now. So I'm Grigori Melnik from the Patterns and Practices team, and I was the producer of the Wasabi, the autoscaling application block.
Yeah. And I'm Julian Dominguez. I was co-leading the development effort for this project.
And we're very excited to talk to you about something that we've added to the platform to enhance the capability of the Windows Azure. The talk is about application scaling to need. And if you think about what the cloud promises, and in particular Windows Azure, is this notion of elasticity many of you are familiar with, which basically allows you to dynamically expand your fleet of cores or the virtual servers underneath in accordance with the demand. So that way you can balance your SLAs with the and stay on budget at the same time. Until recently, if you wanted to achieve the elasticity, well, it's not up to now. It should have been up to November because we shipped in November. But the three choices that you had were pretty much doing your scaling actions manually by modifying the config files.
Going to the portal.
So the portal, and yes, we know that there are improvements to the portal that now your XML configuration can be replaced with the slider, but still that doesn't preclude you from having a human being doing that action, and we know why this is suboptimal. The other option was to go through the use the autoscaler service. And again, there was nothing available from Microsoft. You had to go through third parties. And one of the things to watch for there is that in order for this to successfully work, you actually needed to surrender your management certificate, which may not be feasible in your particular business environment.
And there's an additional constraint is that the autoscaling has to fit their rules, right?
They had to fit their rules. They had to fit the constraints that service actually provides. Yep. So the third option was to actually go ahead and write your own autoscaling infrastructure, calling the Windows Azure Management API, REST-based, which is effectively what we are doing I shouldn't touch this. What we're doing in our solution, and again, this is something that many of the developers would probably enjoy doing that. So sorry for taking the fun out of your day jobs, but perhaps you should think about the main reason why you were employed by your companies or organizations is actually to provide the business value to those orgs. So focusing more on the business logic that delivers value is something that seems to be a bit more appropriate than writing your own plumbing, because by the same token you could be writing your own operating system, right?
Yeah.
All right, so what do we have? How do we solve this with Wasabi? We basically help make your applications more elastic by supporting several types of scaling. So we do instance auto-scaling, where effectively we can
scale
out or scale in. You get extra instances or fewer instances based on the type of rules that you define yourselves. We also support throttling, which is again doesn't deal with your virtual infrastructure, but instead of going and requesting more of your cores or instances, what you end up with is dynamically modifying the behavior of your system to gradually either degrade performance or to offer limited functionality to your trial users, and then make sure that the SLA for your paying customers remains the same. And then you can do the mix of these two. On top of it, we support the custom actions that actually allow you to write your own actions. It doesn't have to be the instance autoscaling or the application throttling the way we've envisioned and implemented. It could be anything you like to do. So these actions generally speaking, they are triggered by one of two ways. They're either triggered by schedules, so the simple way how you would configure an alert or something in your Outlook. So same way, you have the recurrences, you have date times, and this would be something for scenarios where your load is predictable. So when you are building a system and you know that at the end of the week you suspect a lot of expense reports coming in, or in the months of April, especially in the US, it's the tax time, so you're going to get a lot of returns submitted through the system. So you can proactively ahead of time configure the rule, and the Wasabi, or the other scaling block, will actually go and issue the marching orders to provision those to meet those planned demands. On the other hand, there are lots of things that you don't know. You may become a star overnight, or I don't know, something may happen, and out of the blue you experience this flood of users coming to your site, or whatever else may happen. Somebody may upload a very complicated model and expect something in terms of the computation to be done very quickly. So you may need to react to things that you don't know. So for those reasons, we have a way of monitoring for metrics, and then you can react to the times when those metrics hit certain thresholds, and then you can do some actions there. There's a whole bunch of other features that I listed here. I'm not going to talk about them because I think we will be able to touch on them as we go through the demo. But again, the important thing is that in order for you to get the auto-scaling capabilities in your Windows Azure applications today, Wasabi is something that is available. Wasabi is something that you can use today. One catch though. The catch is it's not intrinsically baked in the platform. It's not a service that is in there like caching or Service Bus or ACL or any of those. It's something that you have to download as a reusable component, and host it yourself, configure, and then off you go.
Right. It is a catch, but at the same time, it brings a lot of flexibility because, as Grigori already mentioned, there's a way of putting some custom actions, for example, of what happens when those thresholds are met or the triggers happen. And also you could have metrics coming from various sources that make sense to your particular domain. You might not care about the CPU usage or some baked in metric, but you might care about what's the current number of active surveys or some other metric that makes sense to your particular business. One
of the customers who was participating in our advisory actually indicated very clearly that for them, they don't care how many users are there. They're in the business of doing OCR and online translation. For them, what matters is the number, the metric that mattered to them, that they wanted to react to, was effectively the number of untranslated pages of documents. Okay, or the number of untranslated words or whatever. But that was the business metric that we allow you to define yourself, and it's also pretty straightforward. And then plug it into Wasabi and let Wasabi treat it just like any other metric that you may get from the Windows Azure Diagnostics or other means.
Yeah. So let's explain the two different set of rules that we have.
Sure. So as I mentioned earlier, the schedules are the ones that allow you to deal with predictable situations. And the way you define rules that deal with schedules is by specifying the timetables, of course, and then specifying the minimum and maximum, so the bounds of what you would allow a certain instance to scale up to. We call this rule constraint rules. If you think about it, they are the ones that are actually constraining, right? So at no time your deployment will actually go and exceed the maximum bound or go below the lower bound. And what this allows you to do is the maximum, the upper bound, actually guards your budget. So you know that you cannot afford more than, I don't know, 20 instances, medium size, right? So you will set that, and at no time it will actually go and scale up, unless again somebody intervenes manually. But that's a different story. And by the same token, the lower one will actually help guard your SLA. So you kind of done your initial perf test runs, you've done it in your staging environment, you've done some simulation, you thought about how to extrapolate the data, and you know what your predictable load would be. So you know that 1 or 2 instances may not be enough. So you would say that at this time, minimum, go ahead, give me 5.
Yeah, and if you don't care about any other metric than just the schedule, like you don't care about the CPU utilization or anything like that, you can, of course, smash the 2 boundaries together and say, okay, on Friday, I want exactly 5 instances. And you will get 5 instances. On Sunday, I want only 2, and you get only 2. So
correct. So the other side for unpredictable patterns, what you do, you define the reactive rules. And again, as the word suggests, you react to something. What do you react to? You react to the conditions that you specify, by using some expressions. You can actually do a fairly complicated composite set of predicates there, but those would be based on perf counters. So something that you can, you're accustomed to, your sysadmins are accustomed to as well. The other thing that we're supporting, which is very popular, which actually makes a lot of sense, especially if you are utilizing, the asynchronous processing and you're putting your requests through the Azure queue, we have the queue length. So you can actually say, well, depending on what my queue looks like, or even more, depending on the trend. So you may not care that you have 100 items in your queue length. You may actually care that in the last 3 hours, it has consistently gone up as opposed to going down. So we actually support those type of functions as well. Then the other thing that you can react to is the instance count. Again, something that potentially you may want to use in your decision making, whether you want to scale up or not. And then the custom defined business metrics that we have alluded to earlier. That's probably the most important piece.
So the first 3 ship out of the box when you get Wasabi. Then if you have another kind of metric that you care about, you can just write it, and you'll see that it's very, very simple to just write another metric.
And then just to preempt a question that somebody may be asking, whether there is a metric such as the queue length of the service bus queues. Yes, there is. It's not in the box with Wasabi because the service bus hasn't shipped as the final when we shipped back in November. But what we did, we actually built a hands-on lab that talks about how to define your own custom metrics. And the custom metric that we're defining is precisely the length of queues in service bus. So with one lab, we're kind of hitting 2 birds. And I highly encourage you to do that. Again, if you want that and you don't want to be writing it, just go and get the end solution of that lab. And all the links we'll provide at the end of the talk. And there you have it. You'll have your service bus queue length. So this is a very basic example that simulates what happens with your deployments and when the Wasabi is deployed. So what you've got is the red line representing the maximum instances for a given role. The blue line is the minimum instances, and the green line is the actual count, right? So in this case, we see a default rule only at the bottom here. So there's not much here. I'm just saying at all times it's minimum 2, maximum 6.
Yeah, no other constraint rules that set recurrence or anything like that.
Yeah, no other constraint rule. That's why it's a straight line here and straight line here. And then we have a couple of reactive rules that look at the number of unprocessed documents and then go and increase it by 1 or decrease it by 1. And this is already powerful, but it gets much more interesting when you get the constraint rules and the reactive rules interacting. So here's the diagram that actually shows that, and you see that we've enhanced our set of constraint rules with additional rules that show that daily you want to do a little bit over provisioning here. On Fridays even more so, and then in the late afternoons, that's where all the people are scrambling to get their expense reports submitted. You would want to have the most instances ready to accommodate that load, while your reactive rules stay the same as before. And then you can see as a result, the pattern and the instant count, the constraint rules allow you to go significantly higher here. So you see the green line going all the way up during these hours, where you allow for where you accommodate the higher loads. Now, one thing that I actually noticed here that is probably worth mentioning is the notion of ranks. So Julian, what are the ranks and what are they used for?
Yeah, well, the ranks is a way of knowing which rules should take precedence, because there could be some recurrencies and so on that could overlap in time. So in the constraint rules, it's very, very valuable to have ranks for those. So whenever there's a collision between two sets of rules in time, you can actually get the one with the higher rank. It's just a hint. It doesn't have to be correlative or sequential.
Yeah.
You just put a higher rank, and that means that rule will take precedence. So it's an unbounded rank. Just put it the number that you feel it will be higher than another one.
Just remember, 1 is the lowest, and anything higher than that is
yes,
higher ranking there. All right, so I think it's enough talking about this in general terms. We should go ahead and switch to the demo. You want to do a demo?
Yeah, sure.
Okay.
Let me switch there.
Don't break my machine.
I will try. So here, as you can see, we have a reference implementation. This is, I brought it. Yeah, so that's full screen. So this is a sample application. This is not really something that is production ready, the sample application itself. So the core component, the Wasabi component that deals with the auto-scaling and monitoring and so on, that's a battle-tested component. We've done a lot of quality gates. It passed a lot of quality gates. It's really ready for production.
Let me make it very clear. Not just that it's ready for production. It is used in production.
Yes.
Like we have accounts of big companies, serious businesses running on this and scaling in the matter of thousands of instances, and Wasabi is performing quite well. One of the things that I can talk about publicly, and again, hopefully there will be a public case study published, is that the MSDN and TechNet themselves, those two big properties of Microsoft, they are actually using, you can imagine what kind of scaling issues or scaling patterns they would deal with, right, with the hundreds of millions of those hits every hour. But they are actually now running on Azure. They've gone through the migration, and now the entire systems are deployed to Azure, and underneath they're running on top of Wasabi. So all the scaling up, scaling down, scaling out, all of that is actually performed by Wasabi. So keep that in mind. It is production ready.
Yes. So that said, this particular portion, this UI that we are seeing, it is a sample application. This has not gone through the same quality gates. It's just for you to see this working in action, to evaluate, and you can even take this some of these components and maybe use it in your own dashboard and do some polishing on that. But the point is that this is just looking at the underlying data that Wasabi produces, and it's just building a dashboard on top of it. So for example, as you can see here in the first graphic, you have the light blue section that just has a minimum and a maximum.
So hold on, this is the admin console. So this is not the app that we're scaling. This is another small web app that is used to monitor and to show for the demo purposes of what's happening underneath.
Right.
Right. So there is a different app that is actually running and people are using it, and the tailspin server. Actually, it doesn't matter what it does. We're just scaling it up and down, and we're simulating a lot of load.
Yes. So as you can see here, you have different kind of roles that we are monitoring. And in this particular case, we just selected the one that we call the public website. Mm-hmm. And as you can see here, you have a minimum and a maximum. That represents the constraint rule that Grigori was just mentioning. And the instance count can never go higher or lower than that.
So it looks like it's a stride one. If you go switch to the last 4 hours, you should see the time where we actually provisioned for more. There should be it will update, and we should see. There you go. So early on it was less. Until this morning, we're actually keeping it at the low load, 1 to 2, and then when the symposium started, since we were predicting you all guys coming and bombarding our website, which you smartly hit the URL, nice, with all the requests. So now you can see how that was pre-planned.
Right. So. As we were saying, you can see that the constraint rules change in time. The boundaries, the light blue section changes. But you can see in the solid line, the solid blue line, what's the actual instance count through time. So that's all data that is coming also from this Wasabi that is gathering that data.
What's the difference? Sometimes you see that the blue dot where the actual instance is right on the line of what, and then sometimes there appears to be a lag. What is that accounting for?
Yeah, so this is actually the scaling action. So in the small dot or square, you can see that there's an action being taken by Wasabi. So it evaluated some of the metrics and so on, and it decided that it needs to scale. So it issues a scaling request to the Azure Fabric, and at some point, it actually the instance count changes. So that's why you see a little lag behind. Remember that in Azure, these kind of things takes a little more time. It's not like you react for the last 30 seconds of your load, and you just want to immediately scale up.
So sorry, I just saw that there is a question on Twitter. What if you want to scale to more than 6 services from OHAD? And I can interpret that question in 2 ways. You either asking about scaling across multiple hosted services, and then that's not a problem. You know, as many as you have in your subscription, you can deal with that. Or in case of what you meant here was, since it's number 6, if you were talking about more than 6 instances in this case, then in that case what you would do, again, this is something you define, so it's not a limitation that Windows Azure is putting on you. So clearly you cannot specify a reactive rule that will allow you to go above 6. Again, the constraint rules always overrule. They have higher precedence, regardless how you look at it. So what would you do? You specify another rule. You specify a new rule with a higher rank, probably, to make sure that it actually sits, you know, higher than anything else you already had, because you may actually end up having hundreds or even 1,000 rules. Right. We've had customers and advisors who were talking about, thousands of rules defining the auto-scaling. So you would come up with a new rule, set higher rank, and then you will allow, you want 8 instances to be there, and then you would specify it there.
And by the way, this actually has a consequence. It's not like you define your rules and you forget about this. You have to tune it. So if you feel like you're always hitting the limit, you can realize, okay, what's going on? Do I actually want to budget for more instances, or and you tune the rules?
Yeah, I'm very glad you actually brought it up, because again, the way you deal with auto scaling is not like fire and forget. At least at the beginning. For the first couple of cycles, we envisioned that you are probably gonna put something in place, through your staging, or even once you put it in production, and then you look at your patterns, and then hopefully you're looking through the logs and through the the stats and everything that the Wasabi is collecting for you, because we're writing extensive logs for everything. Right. And then you realize that, well, there could be several types of realization. One realization could be, I had one rule, but for whatever reason, it doesn't seem to be firing up. What's happening? And there are lots of things how you can debug that situation. The other one could be is you've put out all these rules, and then you look at your actually metrics that matter to you, and your utilization is still high, your queues don't go down, and perhaps you under-provision. Perhaps it actually makes sense to go a little bit more aggressively. And by the same token, it could have been the other way around. Perhaps you over-provisioned, and your loads are not high enough, and then you may need to be a little bit more modest in terms of your demand.
So there's definitely extensive logging made by Wasabi. For example, we are not going to get into all the details because it's a lot of logging, but if I was to click on this scaling action, I can actually see that the reason why we see it on the screen, in the graphic itself, is because it's parsing a lot of data, and I'm scrolling very fast, but just to show you that there is a lot of data, and it's actually stored in JSON in a way that it's machine readable.
Yeah, it's all structured data. You can go and parse and slice and dice it any way you want, and either build this type of the UIs, or actually do some analytics on top of this data.
Right. So, for example, you can see at one point in time there were several matching rules, default constraint for all roles.
For the public website. For the public website role. Okay.
Those are the names of the rules itself. So there are several which ended up at one point in time saying, okay, in my public website, I had the current value of 5. I have 5 instances of it. I want to actually go down to 4. So you can follow through all the logs and actually realize what's going on with my scaling.
Yeah, the important thing to emphasize here is that the Wasabi, the underlying rule evaluation engine, will actually take all the rules you have. It will combine them, reconcile them, and it will issue that decision on whether it needs to scale up or down just once at that period of time with its own cadence. So you're not going to end up, if one rule says go up, another one says go down, another one says go up by 2. It's not going to be the jiggery fashion going up and down, up and down. It's actually going to be a smart way of reconciliation. So what you see on this example is that based on these 3 rules that have applied, it concluded that I was at 5, but the desired value according to the rules should be 4, and it will go and issue an order saying please go down by 1.
Yeah. So once that's said, let's go and see how the rules look like in our application. So the rules are written in XML. We actually spend a lot of time to make these to be very expressive and intuitive, even if it's XML itself. So,
in fact, I would argue that if people who are watching this demo in the future, if for the next minute you mute the phone, you would still not the phone, the speakers, you would still be able to interpret what those rules do,
right,
what they define.
And these rules are stored in XML, and the normal way of dealing with this is if you have your autoscaling service be hosted in Azure, you typically want to put this also in a blob storage. So later on, when there's tuning of the rules that needs to be made, you can actually modify that XML in that blob, and the autoscaling will automatically pick it up and command with the new set of rules.
Okay.
Right. So as you can see here, for example, we have a set of constraint rules where we say that the action for this particular rule would be to set the minimum and the maximum instance count from 2 to 5. And this is for different targets. These targets, as you see there, is just an alias that you define in some other place that could mean a role in a particular service, and you could be targeting multiple hosted services, multiple subscriptions in Azure, or just one. That's really up to you.
Yeah.
As you can see here, there's another constraint rule which actually has a timetable that you see that there's a weekly recurrence and so on.
So it's getting a little bit more interesting there.
Yes. So then we have a node for reactive rules where you can see clearly that there are some conditions, and actually complex conditions in this particular case. And we are saying when both of these conditions are met, which if you follow through, it says when this operand, that we will see how this operand is defined, is greater than 5, and at the same time, because there's a null clause there, at the same time, the CPU usage is about 80%,
then scale up by 1.
Then the action is to scale up that target by 1.
And by the way, it doesn't have to be an absolute number. You can scale up or down as a percentage or relative.
Right, you can say add 20% of the instances.
And it will round off automatically.
Yeah. So there you define all the rules. Let me scroll fast down to the section where the operands are defined. So those are the aliases that you saw in the reactive rules.
The operands participate in your definitions of the conditionals for reactive rules.
Right.
Okay.
The operands are actually the metrics themselves, right? It's in this particular case, we have several performance counters that we assign them an alias, but then we decide, okay, what does that operand mean? It means take the performance counter with this name, ASP.NET request rejected, and do an average of those values for the last 10 minutes. So you get a value that you can easily compare against a threshold and decide if that will trigger an action. Mm-hmm. So as we saw, as we already said, there's a few operands that come out of the box. There's the performance counter, there's the role instance count, there's the queue length that you can say, okay, look at the queue named survey analytics, and you defined also as a target in some other place.
For the last 10 minutes and look at the growth rate there?
Right, for the last 10 minutes, and instead of give me the average, look at the growth. There's a few of these different aggregate functions that you can use. You can use the maximum, the last value, and so on. And that will also give you a number. or there's the custom-defined operands.
Those are the ones that are specific to my application that I'm scaling.
Right. As you can see, there's one that says what is the active surveys, the number of active surveys, or what is the tenant count. That, as you can see, there's no. It's not easy for us to just say what's the active surveys. Is this something? This is appropriate to each of the business domains. So you define those operands.
Okay. So do you want to switch back quickly to the sample app and
yes,
show how those rules define? And
yeah, so basically in this sample, because this is a very simple XML file, we actually defined a way to author those rules with the UI. So for example, here you are seeing all the constraint rules that we defined. And if I was to click on one, you can see that there's the same values that we were actually seeing in the XML. There's the start time, the end time, what is the recurrence.
That's the offset, the flag, whether it's enabled or disabled, etc., etc.,
right.
etc.
Yeah, and what is the minimum and maximum instance count, and so on. We have the same thing for reactive rules, and I think for the sake of time.
Yeah, no, but one rule that I would want you to actually show our viewers is in the bunch of the reactive rules, one of the ones that deals with throttling. Let's just look at this one, for example. Tenant web and survey worker burst throttle. So the way the conditions are defined is exactly the same way as on your scaling.
So let me put a little more context. So this rule in particular doesn't deal with instance auto-scaling. This is the one that we were just talking, that there could be other kind of actions.
Application throttling.
This is the application throttling. So as you can see here, we have a set of preconditions, the same way that you define it for the other kind of action. But the thing that changed here is actually what is the action that is taken when the conditions are met. In this particular spot, the throttling rule is expressed in the change setting action. You can see that there's a scale and a change setting action. And there's also the send SMS that's a custom action.
Which we're not going to talk about today.
Yeah, but basically you have a change setting which tells this particular target, this role in Azure, to change one of its settings that is defined in the CS config and the CS def of the application, to change the throttling mode
to this value,
to a particular defined value. Of course, we cannot
do anything in your app. You would have to build your app and design it so it would monitor for this type of changes in the configuration and then do something accordingly.
Right.
So those scenarios when I told you that you switch the resolutions, or you start servicing one type of customers and not others, that's something that you have to implement in your code, right? But at least we have a mechanism of how you can be notified about those changes, and that's what exactly the application throttling action is doing. Now I see one question from the audience here. Dennis van der Stelt is asking whether I implement this in my own app, or is it some service that I run in my Windows Azure account and I can send messages, events to from my app. Can you show?
Yes.
I'm glad you actually went there. I was about to ask you to do that. Yes.
Yeah.
So let's show how we host Wasabi. Since it's a component, it needs to be hosted. So let's show how we do that.
Yeah. So this is not a service. This is something that, as we mentioned, you download the DLL and you need to host it. You could host it on premises, but typically it makes sense to just host it on Azure itself. You can host it in a worker role that it's an extra small instance, because it actually deals with some data, but it's not very CPU intensive.
Yeah, it's not a big footprint. It's not very intensive, and you can easily co-host it with something else.
You don't need a dedicated worker role for it. You can host it in some shared worker role.
Or for the exploratory purposes, you can just run it as a console app even if you want to. We even shipped that for that little console app that we used for our own testing. So if you want to play with it quickly and decide whether this is for you or not.
Right, so in this particular case, this is a separate worker role from the target application that we are scaling, that in the worker role entry point, when we call run, as you can see, all we do is start the auto-scaling, and that method actually has just this.
2 lines.
It gets the instance of the autoscaler, and it starts it. So there's additional configuration that needs to be done on the in the app config in this particular case, that can be done with a tool. It's very simple. It has a lot of sensible defaults. You just might need to specify if you're storing your rules in a blob, you need to put the connection string for that blob. But
you need to specify your targets, you need to specify your certificates.
You specify, your targets actually in the service information. But the thing is, to have this running is very simple. This is something that a developer can do easily. And on the other hand, there's the IT pro or the developer that is a DevOps that could tweak the rules at runtime in a different concern.
Correct. Yeah.
Let's go back to the presentation.
So I'm looking if there are any other questions. None. Okay. So a very important remark, and this is something that we want people to take away from this talk and as you approach Wasabi. Wasabi will help make your applications elastic, but it doesn't make your applications scalable, just like a freebie. You actually still have to design your application to be scalable. What it means is that if you're building the web application, you need to make sure that it is the way you're managing the state, that it's all web farm friendly. So the design for scalability is not something that is now disappearing. You actually have to keep all of those rules and practices and perspectives in mind when you're doing this. This is just a small tool that will end up issuing the marching orders against the Windows Azure Fabric to get you extra instances, but it's not going to turn your application suddenly, a badly designed application, into a highly scalable app overnight.
Yeah, and there are several approaches to design for scalability. We just had a talk recently on CQRS and event sourcing. That's one way of dealing and designing some of your application for scalability. There are a lot of ways, but the point is that you need to design that separately, and we just help you with dealing with the automatic scaling.
Right. So in terms of customizing Wasabi to your business, there are 2 routes you can take. We already alluded to them earlier. You can modify or you can create your own custom metrics. So those are the ones that will be used as operands when you are formulating your conditionals, right? And that was the example you saw. We were using the total number of active surveys and the total number of active tenants for our specific app. And then the other route is to go and specify a custom action, right?
For example, the one that we saw in the UI some seconds ago is send SMS. So whenever we hit certain threshold, we wanted to send an SMS. Or in the hands-on lab, we actually ship a lab that sends an email where certain threshold is met. And so you might not want to scale, but do some other kind of action.
Do you want to show the part of where we define those? The time seems to be permitted, but don't get too deep.
So one other thing is that those are out-of-the-box hooks that you can just drop in some code and it works. But you, of course, have the full source code available. You can tweak it, you can extend it, you can do other kind of changes. So if you need some kind of extensibility that we didn't explicitly thought of and make completely easy, you can, of course, extend the classes, you can modify the classes and ship it the way you want.
Very well. That's
So going back to the application itself, I'm going to quickly show you how you would define.
So this is for the active surveys, right?
Yeah. So
there we go.
So we have the rule that says the active service operand, it just takes a value, and for example, when I have a minimum of, in this particular case, it's 0 answers on a survey, we consider that an active survey. So we want to have what is my current value of the active service. So in order to have that working, here, you just need to implement 2 classes. So the way you do it is, I'm not going to get into a lot of details, but it's inheriting from this data point parameter element. You define what's the name that you want to be seen on your XML.
Okay.
You define the namespace for that in the XML, and you can have all the properties that you want for it. So
you attribute them, okay?
Right, you attribute them, and there's a little bit of boilerplate code that we show exactly in the hands-on lab how that is done. But at some point in time, you override a method that says, give me all the collectors or the factory. How do I collect this data? So I define the contract on how do I specify in the XML, how do I collect that data. So basically, this news app, this creates a new instance of this other class. I told you there are two classes that you need to implement. If we go to that definition, this is another class that just implements a particular interface, a data points collector. It does have just a little bit of boilerplate code that also we explain exactly what it does. But then we have this public collect method that's part of the interface that we're implementing, where you effectively get the data wherever you want. In this particular case, we go to our Sarbase store and get the active Sarbase and so on. So that is a completely
your custom code. You do whatever you want there to get your data.
Yeah, you could go to a SQL database, perform a query, and get a value.
You can do some projection, some computation there in order to return that. But yeah.
Yeah, and effectively you return one or more data points that could be used to aggregate that data and act upon.
On that note, I think it's important to add. Hold on, we're not going to go touch the actions. That's fine. No, but in terms of the implementation of the custom data collector that Julian just showed you. So conceptually, the way Wasabi works is that think of it as you have the two actions or two processes. Thank you. Going in parallel. One responsible for data collection, and it's autonomous. It's separate. It's independent from the other process that deals with rule evaluation, reconciliation, and issuing the margin orders. And in fact, since there are two separate processes, you can pause one or turn one off and keep the other one on in your operations, right? Yeah. So. An example would be if during the production, let's say you chose, for whatever reason, to temporarily suspend your auto-scaling. Okay, let's say you said, oh, something is happening, my rules may not be able to handle this situation, and I want to take my system off the autopilot. Because just by going and interfering and changing the instances in the config of the management portal are not going to help you, because the Wasabi will then say, wait a second, why is this so high when the constraint rule says that it has to be this, right? So you actually, in order to interfere, you actually would want to go and either suspend some of the rules or suspend the entire Wasabi and say temporarily, I'm doing my manual driving here, right? But while that is happening, it doesn't mean that Wasabi stops collecting data. So you may have some metrics that actually require you a longer span of time that you would use the data points from that span. So it will keep on querying all the corresponding data collectors and getting all of that into the stores that later on, once you're ready to put it back into the autopilot, would be used in evaluating those rules. So that's important to keep in mind. Yeah. Another important concept that we have implemented in Wasabi is a stabilizer. And the idea of stabilizer is very simple. It's there to prevent a high oscillation in your actions. So you do not want this to go up and down, up and down, up and down every minute or every 5 minutes or maybe even every 10 minutes. This is something that is not efficient, and the stabilizer basically allows you to specify the cooldown periods, right? During which, so after any scaling action takes place, during the next 15 minutes, no scaling action can take place. Yeah. So the data collection still continues, the evaluation still happens, but no actions can take place. And that way you can stabilize your scaling a little bit.
Right, because you might have just put an action for scaling, but your system has not yet reacted to that. So your CPU might still be high because you're still trying to stabilize the system. And also that marching order to start a new system can take a few minutes. So think of this not like reacting to the last minute of information. You typically want to look at least 10 minutes back in time and act upon more stable data.
Yeah. And you can specify that, in different directions, as you said. You can remember it's on by default. You can turn it off if you don't like it. There's another part of Stabilizer that actually didn't make it to the beta when we shipped it in October, and then the people who previewed Wasabi, all the customers, they spoke very highly, and they came back to us saying, no. What do you mean? This is not enough. We need to have the stabilization not just based on the last action, but we also need stabilization around the, to help with the billing, to optimize around the cost. And it's not a trivial thing, but we actually put into the Wasabi a mechanism that allows you to help with your cost optimization, because now you can actually say that since the billing happens in Azure, at least as of now, on the hourly basis, regardless whether you do you request your instances 5 minutes before the hour, you're going to pay not for the 5 minutes, but for the entire hour.
Right, it's by the calendar hour.
By the calendar hour.
So if you just use the last 5 minutes from 4 to 5, that means, or there's a little threshold, but if you at least use it only for 10 minutes in that hour and then you immediately scale down, that means that you're paying for the whole hour. So we optimize a little bit, having that in mind and saying, okay, do only scale up operations when we are starting the hour so we can take advantage of them more, and only do scale down operations when we are actually reaching the end of the hour, because if we scale down after the first 10 minutes, then we already paid for that hour, so it doesn't actually make sense to scale down at that point. So.
And this is exactly what this code snippet is showing there. It does mention the support for scale groups. Very briefly, a scale group is just a logical grouping to allow you to, say, here's my worker role A, worker role B, worker role C. I want to treat them as a group, and you can treat them with certain proportions, and then that allows you to have fewer rules to deal with those roles as a group, as opposed to specifying in each separate rule for each role there.
Right. So as we already briefly mentioned, there's the developer involved for hosting this service, but at the other point there's also the operations people, the IT pro or the DevOps or the admin, the business owner, that needs to tweak at runtime. Once this service, the auto-scaling service, is running, there's the need to actually update the rules, modify it when the service is already running. You can do it by going directly to the blob storage where the XML is located, or you could go and use some PowerShell commandlets that we shipped out of the box that help you deal with, as you can see here in the set of commands that we implemented, not really author new rules, but manage the rules that are already there, like change the ranks, disable a particular rule, disable the entire rule evaluation process. There's also the notion of encrypting the rules. So if you think that your rules are very sensitive in the nature, you might want to encrypt that, even if it's stored in blob in a secure place and so on. But
because you're transferring the rules over to the blob, you want to make sure that
So it's not a full authoring tools for rules, but it helps you manage the
gives
rules
you
that
a
are
minimum
already
set of what the IT pros and the administrators, sysadmins would welcome.
Yeah.
So the next slide basically shows you how to get all this goodness. We ship on NuGet now, and if you're not on NuGet yet, I highly encourage you to start looking at that. It's a great packaging and distribution vehicle for your dependencies, for your components that you rely on. So the keyword there is Wasabi, and you can also get everything, the binaries, the source, the tests, the scripts, and the Tailspin RI, the sample app, the commandlets that I talked about through the download center. So all of this is linked from the Wasabi homepage and the Enterprise Library Integration Pack for Windows Azure. That is a bigger piece that contains Wasabi, but also has some additional goodness. We also have a lot of learning resources. We have a book, I didn't bring it with me, but you see the cover right there, on building scalable and reliable cloud applications.
That can be downloaded for free online also?
Yes, you get you get the full printable PDF, nicely done.
Or you can just scan it through in the MSDN, that's also hosted online as HTML too. And
there is the reference documentation, there is a sample app that you can learn a lot from. There's a big set of hands-on labs that cover a lot. It covers topics beyond autoscaling. It covers transient fault handling. It covers logging in the Azure. So lots of useful stuff. And of course the Codeplex forum. And these are the list of resources that you may want to refer to. There's additional links and lots of videos that are now being produced. But we have just a few minutes left, and I would like to make sure that we take some of the questions from the global audience there.
Yeah, ask questions with this tag.
Fabian Williams is asking, what is outcome if a rule fires that you implement unbeknownst to you puts you at odds with a predefined billing option subscription?
So, for example, we you specify all the rules that you want in your system. At some point, you might hit the threshold. Okay, you're trying to scale out and beyond the current number of cores that your subscription allows. The thing is, we do not know this beforehand, but we put the scaling request, we call the management API, and the management API can of course push back, and then after a point in time we realize that the scaling didn't go through and so on. So it's not like you break anything, it's just that the scaling operation will not go through. So you might want to start considering, okay, should I go and ask Microsoft to increase my quota of the available cores, which can be done. Yep. It's not a constraint set on stone. But well, you have to deal with that separately. But it's not like it will break the runtime of Wasabi. So there's also the question, can I scale between affinity groups? You definitely can, and in fact you can scale beyond subscriptions altogether. So all your targets do not need to be in the same affinity group. It can be completely separate, it could be in different subscriptions. You can even host the auto-scaling service, as we said, on premises. So it's really a third-party thing that it's monitoring other components, but it doesn't have to belong to the same affinity group.
So are there any other questions? I'm not seeing any, and I think are we out of time? I'm sorry, yes. I may have missed our cues.
Only one left.
Oh, no more questions. 1 minute left. Okay, so what should we talk about? Do you want to briefly go to the Windows Azure? Oh, this is that was a good idea. Let's just show the full list of the supported scenarios as a recap.
Yeah, we can keep it there for when we finish. But so
I actually wanted to go to that link on the Azure official Azure portal. Can you just go to the browser and just, because I wanted to show the how to scale guide. There we go.
I cannot click on it.
Oh, never mind. If you go to the windowsazure.com and then you go into the list of how-tos, you would see that autoscaling is listed as a first-class citizen by the product group. And we're not part of the Windows Azure product group. We built something to enhance the platform. But considering that the product group views this to be such an important topic, we are hoping that Wasabi helps you with, accomplishing it in an easier way, just like MSDN and other customers did.
Okay, so we're out of time.
Thank you all, and enjoy and all the best in scaling your Windows Azure apps. Yep. Thanks a lot.
Bye.